During this video, we will be looking at geometric sequences. So in a geometric sequence, each term is found by multiplying the previous term by a constant. We're going to look at some examples now. First of all, come up with the formula to find the nth term, and then work through some examples. So let's say we had the following sequence: AR squared, AR cubed, and so on. So we can see the first term. So T1 is equal to A. All right, now I'm going to find the common ratio. So if I go the third term, T3 over term 2, that's going to look like AR squared over AR. We can cancel the A's, and then we're looking at R squared divided by R, which gives us R. So the common ratio is R. So now just looking at our pattern, the first term is A, our second term is AR, our third term is AR squared, and our fourth term is AR cubed. So our nth term, Tn, is going to equal AR to the power of n minus 1. And if we look here, so our fourth term, when we look at substituting that in, so term 4 is going to be AR power of 4 minus 1, so it's going to be AR cubed. And that's how we've developed our formula. And that's going to be the formula that we will use for geometric sequences. In our example here, for part A, we need to find a formula for the nth term of the sequence 3, 12, 48, 192. And B, find whether 196,608 and 872 are terms of this sequence. So what I want you to do is to pause the video right now and attempt part 1 or part A of this problem, finding the nth term of the formula. All right, so hopefully you've attempted that. So I'll start by writing our formula down. Okay, our first term, A, is equal to 3, and I need to find R, our common ratio. Okay, so with that, I'm going to go term 3 over term 2, which will look like 48 over 12, and that will simplify down to 4. So our common ratio is 4. So now writing that into our formula, so Tn is equal to 3 multiplied by 4 to the power of n minus 1. Okay, now for part B. We need to find whether 196,608 is part of this sequence. So I will substitute 196,608 in for my Tn, or the nth term. 3 multiplied by 4 to the power of n minus 1. Now if I go divide both sides by 3, that's going to give me an answer of 65,536 is equal to 4 to the power of n minus 1. So now what I'm going to do is change this exponential equation into a logarithm. Okay, so taking the logarithms of both sides, so that'll give me ln 65536 is equal to ln natural log of 4 to the power of n minus 1. So what we can actually do now with this power, with our log laws, is bring it to the front. So n minus 1 ln 4. So now I need to divide both sides by ln 4. And when I do that, that's going to simplify down to 8. It's equal to n minus 1. So finally, plus 1 to both sides. So n is going to equal 9. So yes, 196,608 is the 9th term of our geometric sequence. So again, this time I want you to have a go at trying to identify if 872 is a term of this sequence. So to start with, I'll divide by 3 to both sides, and straight away I can see that that is going to equal 290.6 repeater, 4 to the power of n minus 1. So therefore I can say 872 is not a term in the sequence. Looking at our final example now, so the third term of geometric series is 18, and the 7th term is 1458. We need to find the first term and the common ratio. So again, I want you to attempt to try and solve this part, or this problem. So pause the video and see how you go solving this problem. Okay, looking at it now, I'm going to write down some of the information that I have. So I'll write down the nth term to start with, and then we know it tells us that the third term, so T3 is equal to 18, and the 7th term, T7, is equal to 1458. Okay, so now let's look at rearranging that a little bit. So term 3 is 18 is equal to AR. So if I go 3 minus 1, that's squared. And then 1458 is equal to AR to the power of 6. So what I can do now, I can try and divide these terms. So I might start with the first term here, and I'm going to divide it by the second term. So I'm going to start with the numbers. So that will give me, so 1458 divided by 18 gives me 81. And the a's are going to cancel. And then r to the power of 6 divided by r squared is going to be r to the power of 4. So now, if I take the fourth root of both sides, r is going to equal plus or minus 3. Okay, so now that we have that answer, that r equals plus or minus 3, I'll substitute it into the first equation to work out what our first term will be. So looking at our first term, so T3, which is going to be AR squared. So 18 is equal to A multiplied by plus or minus 3 squared. So that's going to equal 9 once I square it. So dividing both sides by 9, then A is going to equal 2. So our first term is 2, and our ratio, okay, our common ratio can be plus or minus 3.